Autoline After Hours is brought to you by Alex Partners, when it really matters, and by Borg Warner. The automotive industry continues to evolve, and so do the opportunities to define it. Borg Warner, one of the world's most admired companies, gets partners where they need to go. Let's do something big together.
Hey everybody, thanks for joining us on Autoline After Hours. Gary is here, riding shotgun with me.
We missed you last week?
Yeah, I was busy last week. We can talk a little bit about some of what I heard and the like. We've got Frank Markus here from Motor Trend. Great to have you back on the show.
Glad to be here.
Yeah, but our special guest for the day is Yabs Kebede. He's with a company called Remora. And you guys are working on carbon capture for internal combustion engines.
Yep.
And I don't know where we want to start with this. First, just give us a thumbnail. What is Remora? How did you guys get going?
Yeah, thank you for having me here. Appreciate you guys giving us this time. My name is Yabs Kebede, Yabs. At Remora, we build a carbon capture device for CO2 emissions. Our focus at the moment is locomotives and semi-trucks. You can think of our system retrofitting to these systems or vehicles by connecting to the tailpipe. From there, we extract the CO2 and purify the CO2 and produce food grade and beverage grade CO2.
So you're going to sell the CO2?
Correct. Yep.
So that's part of your business plan here,
Yep.
not just make the equipment,
Yep.
but actually sell CO2.
Correct. Yeah. So in the rail application, you can think of our system as an entire rail car behind the locomotive, and that system connects from the locomotive. There's an exhaust duct or piping that connects to our system. And then our system is made up of 4 stages mainly. The first, we're reducing the PM and NOx emissions of the locomotive.
So you're doing more than just capturing
Exactly.
CO2. You're
Yep.
cleaning up the exhaust.
Yeah. So we're able to go from tier 1 to tier 4. And then from there, we cool and dry the exhaust and put it into our carbon capture bed, where we're able to extract the CO2, as I mentioned. And then the last step is where we take out the CO2, extract it, purify it, and have food grade and beverage grade CO2 available. So we have a storage tank on board. As the train stops for its refueling, they offload the CO2. And usually there's, markets, which we can talk about, where CO2 is, highly in big demand, depending on the location you're in.
So it's piped out of the car?
Yeah.
Without back pressure.
Yes.
That's the part I'm really going to hear about.
Without back pressure in the exhaust
Yeah, so
system.
we're not like loading the engine up.
Exactly.
Right.
Yeah.
Yeah, and see, that's what intrigued me, because everything I've heard about carbon capture up to now was that you put it in a tank.
Mhm.
And it's like, well, how big does the tank have to be? But
Yeah.
you guys are doing this chemically. It's almost like a catalytic converter for CO2.
It's not chemically.
What is it?
For the back pressure piece, we have blowers on board that are managing the flow that's coming down the pipe. And then from there, we have these pellets. You can think of them kind of like peas or, little Nerf balls, maybe, where the CO2 molecules have, high preferential, molecular pores.
Yeah.
Where they essentially get stuck behind, while the other constituents like nitrogen and water come out of the end of the bed. And there's 2 beds in this system. So the first bed is where you're processing the exhaust and capturing the CO2, and then the other constituents going out to atmosphere. And then while the other, you're extracting the CO2 and pushing it down the pipeline for the storage tank. So we have a storage tank on board. It's a 10-foot ISO container that stores about 6,000 pounds or 6,000 kilograms of CO2 and offload whenever the locomotives are refueling.
And you're liquefying it.
Liquefying, correct.
Okay.
Yep.
So for those of us who are not train spotters and have no idea about what's going on in the railroad industry, I mean, what are the emissions regulations related to trains?
Yeah. So in terms of emissions, there's a lot of locomotives out there that are, different tiers from the EPA. There's tier 0 up to tier 4, and there's still a lot of locomotives out there that are like tier 4 is the latest, and
Same with cars.
exactly. So and so there's locomotives that don't meet that requirement at the moment, and our system is able to provide that, plus give a revenue generating system by having us sell the CO2 to offset the cost and use of that device as well.
So any of these adsorption systems, it holds on to it, but then it has to be released.
Correct.
Tell me a little bit about the releasing. Is it vacuum? Is it heat?
Mhm.
And where is the exhaust going while that's happening? Are there parallel paths and it goes with this one now, but then that one's being
Yep.
Okay.
Yeah. So we employ vacuum swing absorption, so VSA, and like you mentioned, we have at least 2 sets of beds at a given time. So one is always processing the exhaust while the other is being regenerated, and then we switch, and then the other one is capturing the exhaust while the other one's being regenerated. So you're always processing the exhaust.
And you've got a full tender car on a train,
Mm-hmm.
and on a semi, it's going to fit between the cab and the trailer.
Yep.
Help me, because I have no idea the displacement of a locomotive engine.
Mm-hmm.
How's the scale compare?
Yep.
Does it scale to the size of the engine, or is it scaled to the frequency of the refueling, which is your only opportunity to offload?
Yeah, so there's a lot that goes into the sizing of this system. Our current target is, to fit within an 89-foot flat car. So that will be trailing the locomotive. So that's our current benchmark, and to try to fit in as much performance into that system as possible. So at the moment, we're targeting our system to, like I mentioned, around 6,000 to 8,000 kilograms of CO2 during the locomotive burns 2,500 gallons maybe in a week, or almost in 2-week period they can burn up to 5,000 gallons. So that's like one locomotive fuel tank is sized to 5,000 gallons, so they're burning quite a lot of diesel fuel.
But is that it? We need that much CO2 because we only stop for fuel frequently enough to do that, whereas a semi is going to run out of these little tanks way sooner than that.
Correct. Yeah.
Okay.
I think there is, like I mentioned, I think a lot of our focus at the moment is on the locomotive space and trying to get that device out as soon as possible to our customers. But yeah, I think there's a trade-off of how much space do we want to take, how much power do we want to use. But I think right now, kind of the sweet spot is trying to fit everything within that one flat car behind the locomotive, the tender car you mentioned, so that we're able to put in as much performance as possible, and prioritizing, also hitting that tier 4 emissions.
And what's the energy, consumption of this thing and the mass? So like how many more horsepower do we need for the same amount of payload?
Yeah. Our system power draw in ratio from what the locomotive is using, around 30%. So we're pulling quite a bit of energy, but we're also processing the full exhaust to get it to tier 4. So that's NOx emissions, PM emissions, and then we're also taking that CO2 and purifying it to liquid CO2 and getting food grade. So I mean, all of these processes take energy, but like I mentioned, I think our goal is to have that as a starting point and iterate to a point where we can build a more efficient, less weight and packaging space. So I think as a startup, you have to pick a point and say, okay, let me hit this benchmark. Let me get this out there. Let's see what the operational issues may be. Because I think we have a lot of engineering ideas, but what does it mean to actually be in these environments, and just how do we fit this into their logistic?
So speaking of the environment and logistic things,
Mm-hmm.
so it seemed to me that when a locomotive drives into a place where it's going to be refueled,
Mm-hmm.
it probably has a station that has been built out.
Correct.
And now you're going to have this other 89 feet that's behind it,
Mm-hmm.
and it would need some sort of mechanisms and plumbing and whatnot in order to get the CO2 off. Becomes a big infrastructure problem, doesn't it? I mean, it's so you guys can have all the engineering on board, but somebody's got to build out some.
Yeah, so
more.
we need CO2 tanks at these facilities, or a DTL truck that drives up to these locations to offload the CO2. So I mean, there is an added operational piece to it on how we offload the CO2, but I think there is a lot of interest in how we can essentially be able to revenue share that product, right? So I think we have to understand what that operational piece looks like. So that's why we're engaging with all these customers to pilot these units and see what that means, right? Because I think we have ideas on how that might work, different locations. What does that mean, right? How does this fit into their current operations? And I think that's the piece that we don't have I mean, we have ideas on, but until we go out there and do it and get feedback from our customers, we won't understand. But I think from a capital cost deployment and what type of infrastructure needs to be in place, I think, one is potentially a CO2 storage tank on site, or a vehicle with a CO2 tank on board that can offload it.
And is Remora taking on that responsibility of figuring out that infrastructure?
Yeah, so I think that's something we're working with our customers to figure that out. But I think one of the other key piece to this is, who are the end users of the CO2, right? So they also have a role to play on this. And from the CO2 perspective, one of our interests is, if you look at where does our current CO2 supply come from, a lot of it, a quarter of it, is mined underground. And that's how we're using, for industrial processes or food and beverage. And a lot of the cost that comes with CO2 at the moment in industrial use is transport as well. So a lot of the available CO2 is located in regions where doesn't meet the demand. So with our technology and the rail system, we're able to deploy these, in these locations where there is high demand for CO2, and we're able to displace some of these, non-renewable, or just be able to displace the CO2 that we're mining underground. So with our partners, we're trying to figure out where are these demand locations, and then when we offload these systems, we try to marry that with the customer, right? So there's kind of like there's three partners in this, right? The rail system are able to reduce their emissions. They're able to produce the CO2 from their systems as they're moving freight around, and then match that up with folks that need CO2. And so there's a bit of a, how do we partner with all these folks?
So if there's a Coke plant that happened to be right there, you just
and there's also a lot of applications, from water treatment to welding gases, in food preparation and storage. CO2 is used, so there's a lot of usage of CO2. It's like any commodity that we have. So we're trying to figure out, how do we take these sources that are emitting CO2 and actually use them to industrial benefits.
I got to imagine that even though the railroads may have to deal with a few headaches, i.e., add another car behind the locomotive, figure out ways at refueling stations to move CO2 on and off, compare it to anything else that they need to do to reduce CO2, right? Whether it's looking at hydrogen or some other thing, your solution would allow them to continue using the existing stock of locomotives that they've got, right?
Yeah, I think I think we like to think of ourselves as kind of the tool set in a bunch of the different solution sets. So we're able to provide that. I think the other piece is, with different fuel uses from the locomotives, we're able to further reduce the impact that we are having by burning these renewable or fossil fuels. But I think that is kind of the solution set we're providing, is how do we take these locomotives that are at these, that are widely used, there's a lot of them, how do we provide a solution for this?
Yeah, how clean does it make the exhaust? I mean, take us through a little bit about that. What comes out of the engine and what comes out at the end of the tailpipe once you guys are done with it?
Yeah, I mean, like I mentioned, the first step is we have an after treatment system on board, right? So I think on our current setup that we're testing here at Wixom, we have a Tier 0 Plus engine. And then from there, the locomotive, after being treated, is at a Tier 4 level. So that's NOx, PM, hydrocarbons, carbon monoxide. So that's the first step.
And I'll just throw in, Tier 4 is pretty strict.
Yeah.
I mean, so you're hitting pretty clean standards.
Yeah. And I think there's still, some pieces that, we're testing right now, right? So before we deploy onto the rail system and our mobile system, we currently are building a stationary system of that unit that, we started the design cycle this year. We've put a railroad in place so we could test this in our parking lot. And the goal from there is to, prove out some of these systems, figure out what the issues are from a functionality and just engineering basis, right? What are the issues? How do we get to these requirements that we're trying to meet? So that's what we're testing for right now. And then in the meantime, we're also building our mobile system, trying to figure out how do we package this, make it mobile ready, make it fit a lot of these operational requirements that we have from our customers.
And about the fuel, I mean, I don't know how different locomotive fuel is from over-the-road semi-diesel, which I know has had a lot of sulfur taken out. Is the fuel quality similar with the locomotives?
Yeah. Our we have ultra low sulfur diesel fuel requirement to use our system because it helps with how we built the after treatment system around it, and that's mainly used for at least the systems we're requesting from our customers.
And that's what all the trains use today.
Yeah,
pretty much the same. Okay.
Yeah.
So what's your goal? What are you aiming at when you get to Tier 4? What kind of percentage reduction could we see in CO2, particulate matter, and NOx?
Yeah, so from PM and NOx, you're talking about 80+% reduction, right, from the baseline. For CO2, we're looking for 40+ reduction from the baseline. Or 40% capture efficiency. So we're able to capture 40% of what's being generated. And then, like we mentioned, we have, we have a generator on board that's powering all these devices, right? So we're also collecting the emissions from that device, and taking the CO2 and also cleaning up the emissions from that unit.
So it seems to me, is it possible for a locomotive, basically that's a dirty locomotive, to have after treatment added onto it, separate from what you're talking about?
I think some of the challenges are, the back pressure issue that we mentioned. I think that's one piece, and then packaging a placement, right? Where do you put that unit on an existing locomotive? So I think pairing that two systems with in ours, we're able to manage the back pressure of that. We're able to allocate space and power for that system as well. So I think that's some of the trade-offs that
Well, I guess I'm wondering about is that to what extent is the sale of the CO2 that you guys capture important to this whole system in terms of the economics for a rail company?
Yeah, I mean, I think there's two pieces to that. One is the after treatment. How are they able to, for the systems that they already have, like how are they able to keep those in play, right? I think that's one piece. And then the other is, okay, how much is this system overhead in terms of cost? And I think I can't really talk about what our I guess financial agreements are. I don't have too much insight into that, but for them, the economics is how do we marry an after treatment system that can let us use our current existing locomotives, and then what we're providing is that plus a revenue generating system by selling the CO2. So it allows to offset the cost of what you're doing in terms of operationally and just having that system on board. So I think that's kind of the economics that goes into it from their point of view and us.
What I'm intrigued by with the company is, if I got this right, Remora's been around for 5 years.
Yeah.
And you've gone through multiple rounds of raising funds.
Correct.
And you've gotten it.
Yep.
So I've got to believe the rail companies, the trucking companies, and who else are very keenly interested in this, that you've been working on this for so long and still are able to raise money.
Yeah. I mean, we're fortunate to have really great executive leadership from Paul and Phil. Paul being our CEO and Phil our VP of engineering. But yeah, we've worked on a semi-truck application, learned a lot through that. And what we've seen is, some advantages in doing locomotive initially. So we've pivoted towards that at the moment. But yeah, we have, and I'm sure you might have looked at our website, a truck size scale system at in our Wixom facility as well.
For a Class 8 semi.
Yeah. Right? So similar to what we're doing with our current build with the locomotive, we have a kind of a stationary sprawled out system that is an engineering test bench that's paired with a DD13 that we're testing our different equipments on, and beds and vacuum pumps and all these different equipments, and then we're another piece that we're really excited about in the locomotive piece is we're really leveraging modular design, where we're trying to leverage some of the designs that we have on the semi-truck design and applying it here, so that we're able to modularize and scale up or scale down the system as needed. And then to your earlier point, is like how do we scale the system as as our performance is able to grow, right? So we'll be able to potentially add those modular systems on top of what we have already in that volume or that space, or other energy efficiencies that we can find by replacing those modular components, so that we can scale up to treat larger and larger engines, or larger CO2 reductions from where we are currently.
How much smaller could you go? Are we like the smaller class diesel trucks?
Yes.
Where you don't have as much room on board and as much payload to.
Yeah, I think there's a lot of work that we are we need to do on how do we fit in the packaging space of the semi truck, and how because I think that there's a bit of work that we need to do to understand how well can we fit our current system. I think that's one of the challenges we have. But I think from the way we're approaching the design at the moment is trying to leverage a lot of these components that we have in that design, so that we're able to kind of marry those two different technologies, as we're developing one at the moment.
So indulge my fantasy of imagination here. Theoretically, I'm talking another decade or beyond, could you get it down to passenger cars?
I don't think so. And I think the other piece of this is, the technology is really good for long haul, right? Where you're, I think for a lot of the short, maybe for commuting or just short last mile deliveries and whatnot, you're able to supplement those with electric vehicles or other, emission less vehicles. But I think for long haul trucking or long haul, railroad or locomotive travel, I don't think there's a solution space for that. And I think that's our focus at the moment, is how do we address that piece where there's a lot of CO2 that's being emitted. There's a lot of emissions there, as well as how do we clean those up, and how do we provide a solution to that problem. I think the other, passenger cars or last mile, those are something that we haven't really thought about.
Mm-hmm. So, I mean, isn't part of it though? I mean, the volume of CO2 that you generate with the locomotive is sufficient that it has economic value.
Correct.
And it would seem to me that even a semi truck might not generate a sufficient amount whereby it would make financial sense for the trucking company to say, yeah, we want one of these because we can sell. But I mean, if you're selling, a small volume of CO2, it's like, pff.
Yeah, I mean, I think for the semi truck application, I think if you have a lot of these in your fleet, you could, you're talking about for a let's say 600 gallon long haul trip. That's about 12,000 pounds, 12,000 kilograms of CO2 you're generating in that trip. So it's not nothing.
Mm-hmm.
So I think if you're able to couple those up in, if you are a large fleet owner, I think
so. You go to a depot and you have a volume that would be
Yeah.
sufficient. That would be valuable to someone.
Yeah. So I think like I mentioned, like right now, I think we're one of our mantras in the engineering team. We're a small team, is really focusing on, what's priority, right? Keep the main thing the main thing. And at the moment, it's our locomotive deployment that we're doing at our backyard, our parking lot. So, but I think the economics piece is something that's pretty front of mind for our executive team, and figuring that out with our customers.
There's been little said about the catalyst itself. Are you guys locking down the IP on that before we talk about that? And how's that coming along?
I guess we're working on it, and
so far right now it's really only for diesel, correct? And because I'm imagining, because some of the solutions to lowering carbon for big things, natural gas or whatever, you still get a lot of CO2. This isn't going to really help clean those up. And
no
and what about even bigger things like ships, where bunker oil? No, there's no such thing as sulfur-free bunker oil, right?
Yeah. I mean, so I think for other applications, and how do we think about those? Yeah, going back to what I was saying about how do we make this modular, and the other piece is how do we make this scalable as well, right? So I think there's a lot of different technologies or different applications that we can go into, but I think some of the problems with going really big is you end up having it be kind of a construction project rather than it being a manufacturing. So you're talking about building one-offs all the time, and you won't really have the chance to leverage your designs. So our focus at the moment is how do we make this modular and mobile, because there's a lot of these mobile applications or other applications that we can essentially mass produce these systems for, right? So I think that's kind of our thought process, is we don't want to go chasing some of these bigger and badder things, because it ends up being kind of one-offs, really long lead times, or construction projects that don't.
And would that 30% estimate you had before for the locomotives hold for semis? Because 30%, that's now, that's eaten into what we're carrying.
Yeah. I think I would say for that, there's still more work to be done. And
okay.
I won't comment on that.
So how many locomotives are there out there right now that could use this? I mean, if you guys were...
Thousands. I haven't checked where the latest count is, but there's quite a large market for this. If you think about who's the largest fuel burning entities in the U.S., I think outside of the Army, I think it's locomotive industry. So they're burning. There's a lot of fuel being burned to move freight around. So there's quite a lot of opportunity.
Yabs, what got you into this? I'm curious. Tell us the story.
Yeah. So Remora was founded in 2021. I had some connections with the co-founders, but I think one of the things that I was itching for, as I've always had a very hardware background, where I like to see the things that I'm working on and feel the things. I think I mentioned this to you last time we met. In my collegiate time, I worked on hybrid racing. So, just being able to my background is electrical engineering and computer engineering, but I like to see the things that I'm working on, even though it might be software or very small hardware. So, but yeah, I think just being able to work on a project like this, that's very difficult, but also, solving some of our, current issues was very interesting. And, having it be, done back here, which is Michigan's where I grew up, was very intriguing for me.
So okay, Wabtec and Progress Rail, which are the two big locomotive manufacturers in the country, the Wabtec offers Flex Drive, and Progress Rail has EMD Joule. So, A, why didn't you go with one of those guys, given your electrical engineering background? And B, why is the Remora approach perhaps better than going with one of those locomotives?
Yeah. So, like myself going to Wabtec is what you're mentioning?
Well, or Progress Rail.
My background is I originally was working in embedded systems for 5G software. But yeah, essentially I'm always chasing kind of the hard problems. And I think this was interesting for me. But yeah, I think just being able to, be able to lead a team and work with, just diverse engineers is very intriguing. And then being able to work in a small team is, you're able to get done a lot of stuff in a year. So I think there's a lot of interest in just our team and the knowledge there. But yeah, I think, like I mentioned, I think I'd like to, and we like to think of our solution as just another solution set and all the different technologies that people are building. And, I think we have not only, the technology, but I think the unit economics as well to make it work. So I think that's what we're trying to prove out by doing these pilots, doing these engineering builds in our backyard, in our facility. So, yeah.
Real good. We're going to have to wrap up this segment of the show, but Yabs, thanks so much for coming on the show. Very interesting what you guys are doing.
Yeah.
We're going to definitely have to keep an eye on it. And just so the audience knows, when he says, we got a locomotive in our parking lot, I drove by their place not knowing about Remora about a month ago and saw a locomotive sitting in a parking lot and wondered what the heck is going on here.
Yeah.
So when you mentioned a parking lot, I want the audience to be aware of that.
And we have security. Just FYI. Yeah.
Real good. So thanks again. We're going to take a quick break. We'll be back to talk about news of the week.
The automotive and industrial sectors are undergoing a historic transformation. Electrification, digitalization, supply chain reinvention, regulatory shifts. The pace is accelerating and the pressure to adapt is real. This is not a time for hesitation. It's a time for bold decisions, backed by fast, effective execution. You need a partner who understands complexity, from factory floors to boardrooms, and delivers measurable results. That partner is Alex Partners, when it really matters.
The automotive industry continues to evolve, and so do the opportunities to define it. BorgWarner, one of the world's most admired companies, gets its partners where they need to go. Let's do something big, together.
All right, we're back. Talk about things that have been going on in the industry. I'm sure you got a list there, Gary.
I do, but I could quiz you guys.
Oh
boy.
Quiz us. Here we go.
All right, so this vehicle was introduced on October 2nd, 1959, keeping with the October 2nd theme of being today. And it was in production until 1969.
Oh, because my first guess was Edsel, but 59 to 69, 10-year run. Can you give us another?
It is not just some random vehicle.
Not like an International Scout or something.
No. It's not. It's not. It's a vehicle that even car people would be aware of. Not car people.
59.
50, can you give us any other little?
Oh, it's gonna. Okay, it's gonna
that would give it away.
It's gonna be so easy.
Robert Foster says Corvair.
Robert
Corvair.
Foster is correct.
A Corvair. Wow.
Okay.
See, and
That was from the chat room. Robert Foster.
Yeah.
Congrats, bro.
Okay, what surprised me when I looked into this was the fact that Ralph Nader's Unsafe at Any Speed was published in 1965.
Took him a while.
So it took him a while for him to come to the conclusion. It was a criticism of the rear suspension that was the problem.
Which by 65 was changed anyway, right?
And
Yes.
then the other thing is that even with that controversy about the vehicle that presumably the book generated, it still had half of its life ahead of it. It was bizarre. But I want to ask about something that is not news of the week. That Frank, in Motor Trend, you had a very interesting comparison of Navigator, Escalade, and Wagoneer, which I thought was fascinating. And one of the points you made in there, where you were talking about you were talking about the screens. All of them have ginormous screens inside them, and you were saying something about how you're wondering if a decade from now, whether the hardware is going to be sufficient to deal with the software. Talk a little bit about that.
Exactly.
I thought that was great.
I mean, screens at home, right? I mean, they were 120 was great. 720 started out, and then it's 4,000. Now it's 8K coming and whatever. Whatever you build into a car is going to be obsolete in a little while. So there's that. There's also the fact that it's hard to find anything to watch on that. That second screen, if the person's going to watch, the driver can't see it, it's antisocial. I don't know why you want that. That's why I like the Lincoln one. All the information's up there. Everyone can look at it's weather and, fuel economy and so on. So yeah, that was my favorite of the big screens.
Yeah. I thought that was great. So what, give us your impressions of these.
Yeah.
These
basically, Navigator started that whole thing, but Escalade kind of, perfected it, and they're still hard to argue with. I mean, power doors, the V8 was the slowest practically one there, but it just sounds so much better. And, it's only the slowest if your foot's on the floor, which, how many times have you put your foot on the floor?
That's a good point. That's a really good point.
In a powerful car anyway.
Right.
No one, so anyway, the Wagoneer, nicest riding car there, far and away. I think it rides better than a Cullinan. I had them back to back once a while ago. So yeah, but stodgier, the Lincoln and the Escalade, when you open the door, they really wow you.
There's
and
presence.
Yeah, and the Jeep's a little more staid in it's beautiful, perfectly executed, no chintzy stuff, even down on the low on the door and whatever. The other one's kind of, but yeah.
One thing occurred to me was that, okay, so you have the Escalade from Cadillac, which is General Motors luxury division, right? You have the Navigator from Lincoln, which is Ford's, but you have the Wagoneer from Jeep. Why does
Well, it's kind of from Jeep. You got to struggle to find the word out there. They were going to try and make that their upscale brand.
Right.
I think they've kind of backed off of that.
Didn't work.
No.
But why isn't it Chrysler? I mean, Chrysler basically has the Pacifica.
Yeah, because the Jeep brand has got a whole lot more panache, especially at the upper level, than the Chrysler brand does today.
I think that Stellantis is missing something here. I think that people who buy Jeeps are not saying, I'm buying luxury, okay? That if you were to have something, bring back the Aspen name, perhaps.
But it was you have to remember that it was far and away the most luxurious thing Chrysler, Jeep, AMC sold at the last time the Wagoneer was around, remember? I mean, they charged a lot more for it. They made a lot more money on it. I mean, so they're just trying to hark back to those days.
But who remembers that? Besides
old people, I know.
Yeah, I was going to say, and they don't need them to buy vehicles. That's not the. So okay. Yesterday, September 30th, yesterday's the 1st. So day before yesterday, $7,500 went away. Earlier this week, Ford hosted an event at Michigan Central, Accelerate, which was about the essential economy, meaning people who work with their hands and do things that are essential to keeping the lights on and building cars and tool and die and so on and so forth. And Farley mentioned about how he thought we don't need $75,000 electric vehicles. Nobody wants them. That it's all about smaller commuter city vehicles, and that he thinks that the size of market for EVs could go down to 5% like that. What do you guys think?
And Slate get a big bunch of it, right?
Yeah, right. Yeah, no, I think Farley's right. I think we're going to see a big drop in EV sales right now. We've seen that happen in other countries that yanked their EV subsidies. I will point out, though, very interestingly, Germany slowly phased out its subsidies throughout 2023, chopped them all off at the end. EV sales took a pretty big nosedive. They didn't fall by half, but they fell by a quarter. And year to date, right now, 2025, they're almost back to where they were before the incentives were yanked. So why? Because more EVs came out, lower priced EVs came out, the infrastructure got better. I think we could see the same thing happen here.
I think the zeitgeist over there is completely different too, though. There's no make Germany great again, no weird, anti-EV sentiment that
they have not been
here.
Politicized.
Right.
That's right. But, look, good product solves every problem in the auto industry. And if you come out with an affordable EV with a good range, I think you're going to get more and more people to start buying them. But I'm no Pollyanna on this. I don't see EV sales coming back to where they are right now. I think they finished last month at a 12% market share. By the end of this decade, including PHEVs, the experts I've talked to say they could go to 20%, but it's going to take years to claw back up to that level.
So, I mean, one of the things that I was wondering about when I was looking at the sales numbers, so one for Ford and one for General Motors, which sort of struck me. So, year to date for Ford, the total number of electrified vehicles, so this means their EVs as well as their hybrids, was 242,298 vehicles. Camry alone, which is a hybrid-only vehicle, was 234,369. So it was a difference of about 8,000 vehicles that Camry was. So all of Ford and Camry is, and it's a sedan, right? Nobody buys sedans, do they? Oh, wait a minute. A whole lot of people do. So, Frank, do you think the Toyota powertrain strategy makes a little bit more sense? And has made more sense going forward?
It's hard to argue against that in the face of everything, right now. That's for sure.
Yeah, I think Toyota, they bet heavy on hybrids. They've been backing it to the hilt. Certainly in the marketplace right now, outside of China, and maybe even China to a degree, a hybrid heavy strategy is a really good strategy to have.
So another thing that I thought about is, okay, now we'll go to General Motors. So year to date, they've sold 144,668 electric vehicles. Okay.
In
so
the US.
In the US. So then I looked at the sales of the Tahoe and the Yukon. Okay. So you combined them and they sold 154,000. So they sold a lot more. Now, as we well know, the margins on things like Tahoe and Yukon are pretty substantial.
Some of the best in the business.
So if you're making and selling more of these two things versus all of the, the full suite of, from Blazer EVs to the Optique from Cadillac, it's just like, isn't it General Motors' fiduciary responsibility to make more Tahoes and Yukons and fewer electric vehicles?
Depends where you want to take your company in the future. I mean, I would argue that electric is the future. I believe we're going to get there because you're going to see the cost of internal combustion engine powertrains only go up. We talked about Tier 4 criteria emissions. The industry's still not there yet. It's probably going to have to go to gasoline particulate filters to be able to get there. There's even talk that maybe they're going to have to go with heated catalysts, to prevent cold start emissions, which is where the most emissions come out. And interestingly enough, while the Trump administration has eviscerated anything to do with EVs, it has not touched Tier 4 criteria emissions. So the industry is going to be putting more cost into ICE. At the same time, we're still continuing to see improvements made in BEVs, costs coming out of them. And, the point's going to cross, we're very close to it in the US market, where it's going to be cheaper to make an EV than it is to make an internal combustion powertrain vehicle. And so for big vehicles that tow or haul, Farley's right. You got to put a massive battery in there. It's really hard to pencil the numbers, but in anything that's, for everyday commuting or running around with not long trips, EVs are only going to make more and more sense to more and more customers. It's the future.
Sure seems that way.
That EVs are the future? And when is the future?
That's a sliding scale, isn't it? I mean, I'll tell you that at the IAA a couple weeks ago, Horse Powertrain, this new outfit to sell range extenders and that sort of thing, big splash, a whole bunch of, they got an engine too. It's like a briefcase size.
Yeah, Horse is a spin-off that Renault started. They put all their ICE powertrain into Horse. Geely said, we're interested. Volvo was the first part of Geely to be involved. In fact, we're going to have a guy from Horse on the show in 2 weeks. And they've got an office here in Detroit. Yeah. and they tell me people are knocking on their doors here in Detroit saying they're interested in that.
Well, speaking of Germany, in the show last week, we talked about this a little bit. And so ZF has announced that it is going to be laying off 14,000 people by 2030. Today, they basically announced where 7,900 of these people are coming from. That's from their electrified powertrain technology division. And this is a quote from their announcement. Development activities in the product groups, including onboard chargers, DC converters, and electric beam axles, e-beam, will be discontinued while the development of innovative products such as Thermos, the ZF thermal management system, or the 8 HP Evo plug-in hybrid transmission will be consistently driven forward. So basically, the e-beam axle, which consists of a motor and an inverter and a drive system. So basically, plug this into your pickup truck and you've got an EV. Gone.
Right.
And this thermal management system, which is basically to manage the temperatures of electrical systems to make them more efficient, that'll stay. But they're really counting on this Evo transmission, which is for hybrids, and they point out you don't need a plug. It's better than it's lighter and cheaper than a plug-in hybrid transmission.
Yeah.
Well, the transmission doesn't care if there's a big battery or a small one.
Right.
So I don't know what they mean by that, but
Well, they're talking about the transmission itself. So if you have a PHEV setup, and
I suppose the PHEV would have a bigger electric motor to make it drive,
right.
Yeah. Here's the problem: is that too many suppliers jumped in with one of these e-beam axles. ZF has got one. American Axle showed one. Magna showed one. I think Dana showed one. And, they were all hoping to get the business, right? And I don't know if any of the automakers have sourced that. Maybe they have. But, look, definitely in the U.S. right now with the current administration, it's yanking anything it can do that will prevent EVs from being adopted. They're not growing as fast as was thought would be the case in Europe, even though I mentioned in certain countries like Germany, Denmark, and the like, EV sales are quite strong. But throughout the continent, I think they're running at about 15 or 16% market share. So, probably roughly double us, but still not enough. But I still say, give it time. The days of the ICE market segment are only going to, the market segment for ICE is only going to shrink. That for BEV is going to grow.
And didn't I just hear, aren't we at like 120 per kilowatt hour, I think, right now? Because for a long time they said that at $100, it's about parity. And if you get much below that, it's,
it's good. Yeah, right. And it depends. Are you talking about the cost of the cell, or are you talking about the pack? So we should talk packs cost, because that's the real thing. Yeah, I think we're very close to $100 per kilowatt hour. But the newest numbers I'm hearing is it's really got to be $60 to $70.
On the automaker side or the customer side?
I'm talking.
I think that's important.
Yeah, Sean's saying, is it to the customer or to the automaker?
I think that the smaller number is for customer,
no, the other way around. Yeah.
Smaller number automaker, bigger number.
Yeah.
Like 100 to 120, I think, is where it starts reaching.
Yeah. Anyway, the powertrain experts I've talked to have said before this decade is out, we will have crossed this point in the United States where it's cheaper to make a BEV than an ICE vehicle.
And you keep seeing new little incremental changes. Like there's one now, electrode to pack, right? Yeah, this is a new thing. We're going to just vacuum pack the two electrodes with a little electrolyte in between them, and you stack those in there, and now the energy density's improved and whatever. Yeah.
Well, the fastest way to take the cost out of a BEV is use a smaller battery.
Yeah.
And so there's a lot of really interesting stuff going on total systems approach of making a vehicle more efficient. And I saw a presentation recently where one of the suggestions is putting carbon nanotubes embedded in the windshield so that you can use a fraction of the energy to de-ice or defog the windshield. And instead of heating the entire passenger cabin, you just have these microjets that are blowing warm air on the passengers, and the armrests will radiate heat. So again, you can downsize the battery, and every increment, you can take thousands of dollars of cost out of a battery just by making it smaller.
But imagine the cost of replacing that windshield.
Well, that's a big problem.
SafeLight will just become the most valuable company on earth.
Yeah,
replacing all these windshields.
Look, all that ADAS stuff mounted behind it has already sent the price of windshield replacement up dramatically.
Yeah.
So, okay, the car companies all did fairly well. I mean, even Stellantis broke its losing streak in the third quarter by actually having a positive result, 6%. What do you guys think accounts for the overall sales that these companies have, especially since we've talked a lot on the show about the affordability crisis, and according to Cloud Theory, today's average price of a vehicle is $50,000.
Yeah. Well, part of what drove good sales last month was a mad rush to buy EVs.
Yeah.
sales shot up more than 20%. As we talked about, they hit over 12% market share. They had been down around 8%. So, there was like well over, I want to say 430,000, over 400,000 EVs sold just last month. I mean, it was a banner month. And I think that had a lot to do with it.
What do you think, Frank?
I'm with you there. I mean, I think we're going to see just as I would like to know if the German, when those numbers, how much of that was inflated before then. They had a longer ramp down.
They did,
of theirs, so it might not have had the same situation, but
right. It was it went down in phases over the course of a year, so you didn't have a mad rush like we just did here. And it'll be interesting. GM and Ford pulled a really slick move. Their dealers have got all these EVs in inventory, right? And they want to be able to get the $7,500. So literally last minute, GM Financial and Ford Credit, which is their in-house finance arms, ran out and made deposits on every one of those EVs.
And how many do you suppose it is?
I don't know, but
how long will it take? How many days supply? When does the 7,500 really run out for all of those cars?
Yeah.
So, and are those cars all going to be demos now? Are they all have an in-service date with a warranty starting? That's
a really good question. That I don't know. But all I do know is that, GM and Ford said they cleared this with the IRS. And so now dealers can offer a lease with that $7,500 discount baked into it for everything.
That's also for sales too, right?
I don't know why this does not apply to a sale. Well, a sale's a sale, right? And if the sale happens after the incentives expired, sorry, Charlie. But if you come in to do a lease on an EV right now, which I would argue is the best way to do it anyway, because in 3 years, there's going to be better EVs on the market. So you can go get a lease right now from GM and Ford for an EV that's got the $7,500 baked into it.
So what does this do? Okay, so let's say it's a Mach-E, and it's the Mach-E that they have on the lot, which I'm sure they sold lots of them in the last few days. But what does this do to the new Mach-E's that get shipped into the dealership? Does somebody say, no, I don't want one of those. I want one of those that's $7,500.
I want the old one. It's cheaper.
So, I mean,
they're going to have to do something. I mean, the Ioniq 5 just had discounts applied to it in the $6,000 to $9,000 range, I think. Yeah.
Huge cuts. So, I mean, with the new Mach-E, they're going to have to do something. Whether you put more standard equipment on, that had been optional, or you've got some sort of finance deal. There's going to be deals.
Sweeten it up somehow to where you got to have this one now, know.
That's right.
Special color.
Probably take more than a color.
Right.
So what else did we have happening in this industry this week?
Well, I'll tell you one thing, and I'd like to get your opinion on this, Frank. I've been very bullish on e-revs. And, because if you're worried about range anxiety, don't worry. It's got a gasoline engine. You fill it up. It's going to charge the battery. You keep on going. If you want to drive on electricity, plug it in every night. You can drive 70 miles or thereabouts. And I thought for the American market with big pickups and big SUVs and towing and all that, an e-rev seems to make all the sense in the world.
Where you just buy a Tahoe. But
yeah, right. But now I'm starting to hear that maybe e-revs are not well suited for the American market. That in China, they're doing very well in China. That segment is growing very, very quickly. That, if you're in a smaller vehicle and you're not driving long distances at 70 to 80 miles an hour, an e-rev can be perfect. And I'm told that the e-revs in China, you can barely hear the engine. You don't hear it start, you don't hear it running. Whereas if you're going to have an e-rev, let's say a pickup towing a trailer, going up a grade, that engine's going at max power. And it's going to keep on running even when you back off the throttle pedal. Or if you put your foot back, it's still going to be at the same RPM. So you're going to have this drone that's going to be tamped down and maybe noise canceled to make it quiet. But you're going to hear this running in the background, and it's got no relation to what your right foot's doing on the throttle. And so
that was everyone's complaint with the CVTs early on,
right?
The motorboating or whatever,
right?
So yeah, I mean I haven't been in one to see how quiet did they get that
Nor have I.
V6 or whatever hooked up to that thing. I don't know. So.
Right, because I've talked to people who have driven the E-Revs or the Reeves, as they call them in China, the extended range ones, and they go, oh my gosh, it's so quiet, it's so well done. But I've talked to others doing development work here, and they're like, I don't know if our customer is going to go for this.
So do you think the Chinese vehicles are as loud as the ones that are being developed here, yet they're not?
It's the duty cycle. It's the size of the vehicle. So like, Stellantis has said they're going to come out with an E-Rev, even though it's been pushed back a year. And I wouldn't be surprised if it gets pushed back again with a naturally aspirated 3.6 liter V6. Whereas in China, they're using 1.5 liter turbos.
But these are in sedans versus Stellantis is putting it in a truck.
Full-size pickup. Yeah, the Chinese applications are in passenger sedans.
And that horsepower thing was this big.
That horse has?
It's a 4-cylinder, not a 3-cylinder.
Yeah.
It's probably going to be a little smoother than it would. Right. Yeah, I bet that. And that they made it so that it will fit where under your frunk or whatever. If you had an electric car, ready to go, and you're like, pulling the ripcord on that idea, this will go right in the same spot, and then it's out of the way and it's isolated and so on.
The Nissan Ariya was an E-Rev in Japan, or it was offered as an E-Rev in Japan. Extended range, and it was. My understanding, suggested that the American arm of Nissan could take it, and they were, no thanks. You drive these things at 70, 80 miles an hour. The battery's depleted. That thing's running all the time. It's making too much noise. So
you're souring on E-Revs.
Well, what I'm realizing now as I learn more about them is from a duty cycle standpoint in full-size trucks and SUVs, the way Americans drive, it may not be the solution.
So I've got to ask, is autonomy over as well?
No, autonomy's not over.
This is the year of autonomy, according to John.
Yeah, because we're seeing rapid global expansion of robotaxi service. And global is the key word. And it's happening in the US, it's happening in the Middle East, it's happening in China, and a few other countries too. And it's only.
Have you guys tried them out?
No, I have not. I'm dying to.
I went to Austin and we tried to do a race, between a Tesla robotaxi and a Waymo. We could never get them to come at the same time. What we didn't realize is that the Waymos are not allowed on the highway yet. So if you pick a route that would be best served by a highway, they wouldn't send you one of those. And we were trying to utilize that whole, get a 15-minute ride up the whole, service area. And so we never got one. Anyway, big difference in the two of those. There were a lot of glitches with the robotaxi, which still has a guy riding shotgun.
This is the Tesla car.
Yep, it's just a Model Y that's got a little bit of extra stuff on it, not much, but it was smoother. What was striking and startling is that Waymo with a zillion lidars and stuff all around. It knows where everything is all the time, so it'll whip up and stop and go faster than you would, because you'd be like, did I look this way? And when I was looking this way, did they come? You want to look both ways a couple times, whatever. This thing already knows, so. It just runs right out there. It was pretty impressive, and not as smooth as the Tesla for some reason. But
calibration, right?
Yeah, and maybe that wasn't their number one worry with that thing. So,
I read something this week that there's an issue about what happens for a moving violation.
Right, there's that U-turn.
Right, so. That hasn't been worked out yet.
No.
So, and this is for a Waymo vehicle.
My question, though, is the U-turn that Waymo pulled. Did it interrupt traffic? Did it interrupt pedestrians? Was it just an innocuous U-turn? And did the cops go, we're going to pull that guy over? Or, I'd like
it
to
has
know.
to be posted because, I mean, unless it's forbidden, I think in a lot of cases it's illegal. It is legal. So I don't know what the situation was down there.
To me, if it didn't interfere with traffic or pedestrians or anything, it's kind of a big deal.
Okay, but what if you were driving that vehicle?
Yeah.
And the guy's like, here you go. Here's
Yeah.
your ticket.
I'd say, officer, number one, it depends. Look, if I cut somebody off, it's like, yeah, I deserve a ticket. If I wasn't aware that U-turn was not legal, and if I didn't,
What is the line about ignorance not being a excuse for?
I'll tell you, because I've had some recent experience with this. If a cop's having a bad day, they're out looking for things to pull people over for. I'm sorry, that's just human nature. It's true. And so, was this guy having a bad day and going, I'm going after that car?
So, isn't this putting a slight reduction in the possibility of this being the year of autonomy?
No, because I'm sure what Waymo did, they went into their algorithms and said, don't do U-turns.
And there is nobody doesn't know that's a Waymo. Nobody doesn't know that's an autonomous car.
Right.
So they must have wanted to pull over an autonomous car or try to or whatever, you know.
Yeah, look, if the cops suspect anything in a car, they'll look for any reason to pull it over.
Yeah.
So that they have, cause. But and then maybe, yeah, you're right. With all the whizzing things on,
the Teslas, by contrast, no. I mean, they just say robotaxi kind of, quietly on the door. You wouldn't know that wasn't.
Yeah.
So what was the guy doing who was in the car?
He was there, as we noticed, when one of them started to make a left turn into a restaurant and stopped and just kind of went open loop for a minute. He hopped out and went around and got in the car and finished because he was kind of blocking traffic a little bit. So that's what they're there for. And they can force it to stop and pull over with a push of a button. It's that kind of thing. So we're not supposed to talk. They're not supposed to talk to the people in the back seat.
Really?
No.
But you never got the Motor Trend race between.
No, we didn't. We weren't able to go in the same place at the same time on this one. But we got enough rides in the two of them to kind of assess them, and we came back saying, "Yeah, the Waymo has got a stronger, brighter future."
So you personally, would you use robotaxis in the future?
Yeah, and I think you would. The people I've talked to that live in the areas where these are going, they're like, "Yeah, it's novel the first few times, but after that, you're just looking at your phone. You're not paying any attention, just like you wouldn't if somebody was driving. It becomes second nature."
Mm-hmm. Real good. Interesting. So you got anything else burning or?
Nope.
Okay, we're going to wrap it up then. Frank Markus, great to have you back on the show.
So glad to be back.
Always. Yeah, no, this was really good. Gary, always having a lot of fun with you, and I hope all of you enjoyed having tuned in.
AutoLine After Hours is brought to you by Alex Partners, when it really matters, and by Borg Warner. The automotive industry continues to evolve, and so do the opportunities to define it. Borg Warner, one of the world's most admired companies, gets partners where they need to go. Let's do something big together.